Definite integration problem 4. Y equals x to the power of n. A, the area will be equal to integral y dx equals x to the power n plus 1 over n plus 1 plus c. First part says we should evaluate that function. So we've got this function, we're just going to evaluate it. We're not calling it area. That's what that meant. Just evaluate it. So when you're evaluating that, it's just integral 2 minus 2 x cubed dx will be equal to, well, so we're still applying that integration process. So that would be x to the power 3 plus 1 over 3 plus 1 using the square bracket 2 and minus 2. That's the lower limit boundary and that's the upper limit boundary. X to the power 4 over 4, 2 minus 2, and that will be equal to 2 to the power 4 over 4 minus 2 to the power 4 over 4, and that will be equal to 16, 2 to the power 4, 16 over 4 minus, that's plus 16 because minus 2 to the power 4, that power is even, so that will be positive. So that will be 16 over 4, and that equal to 0. So the integral of 2 minus 2 x cubed dx equal to 0. So that's why you have to be careful with the question. It's just asking to evaluate. Now the B part here is asking us to find the area. Find the area between the graph or the curve y equals x cubed and the x-axis and the line x equals to minus 2 and x equals to 2. So let's sketch the curve first. So the curve is y equals x cubed. Well, this is first quadrant, second, third, and fourth quadrant. This is a positive a here, so it will start from the third because it's cubic. And the curve will approach the x-axis and all the way to the, so that's what the curve looks like. But we're looking for the line x equals to minus 2, so x equals minus 2 here, so that's minus 2, so that's the area between the curve and the x-axis. And we're looking for x equals 2, so x equals 2 here, and the area we're looking for is between the x-axis and the curve, so here it is, and that 2. So we want to find between x equals minus 2 and x equals 2. So we integrate minus 2 and x equals to 2 x cubed dx can be written as integral minus 2 to 0 x cubed dx plus integral 2 to 0 x cubed dx. So that's a good way to do it because we're not going to have a negative area, so we can find the area between minus 2 and 0. So minus 2 and 0, lower limit, upper limit, and 0 and 2. We just add them together. So now to find the area now, that would be applying the integration process. So that would be x3 plus 1 over 3 plus 1, 0 minus 2 plus x3 plus 1 over 3 plus 1. That would be 2, 0. We know the first one is 0 disappears because, well, let's finish this one. So that's x to the power 4 over 4. That will be 0 minus 2 plus x to the power 4 over 4, 2, 0. So that's the first bit here and then the second bit here. So when you have a 0 here, that goes 0 over 4 minus 2 to the power 4 over 4. That's the first part. Plus 2 to the power 4 over 4 minus 0. So that's the second part. We know that's going to turn out to be minus 16 over 4, which is minus 4 for that one, plus 16 over 4 is 4. Because it's an area, we're just going to add the magnitude of the area. So that's just going to be 4. And that would be 4 plus 4. That would be 8 units squared. So the area we're looking for would be equal to 8 units squared. So you see, when you evaluate it, it was 0. But when you work it as area, it's the size, the magnitude of the area, not the direction. So because area is a scalar quantity, it's not a vector quantity. So therefore, it's 8 units squared.